Please put away your phones. Take out your headphones. Phones away. Pencil out. Take out the headphones. Weirdly, this one's sort of a review lesson. It sort of goes over everything we've seen in the chapter, all in once. So I'll keep it moving. But your job, let me know your questions as we go. This is supposed to be everything we know in one lesson. So, you could potentially use this as a reference sheet to do any question in the homework. Yes? You can put the cubes away too. That would be great. Fabulous. Review of graphing. Do you remember graphing? One way we have to solve these is by graphing. You can not like graphing. I give you permission to not like graphing. Okay? But this is one of the methods to solve. How does this work again? Y equals 2x minus 5. What's this one, the negative 5? What does that tell you to do? It's the y-intercept. You can put that right on the y-axis. There you go. Then this one. What's the 2? Slope. 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 Which, if we're going to use it as 2, we think of it as over 1. We actually want the fraction there. The fraction will help us in what we're doing. Yes? So, to graph this thing, rise 2, run 1. I know some people didn't like graphing, but it's not that bad. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. I like getting all the points across. Of course, you don't have to do that. You can use your ruler. Just draw a line all the way through. There. First line done. Second line. Same stuff. Shh. Shh. This one. Y-intercept is 7. And this time, slope is negative 4. So I start at 7. How do I use the negative 4? Down 4 over 1. Put it over 1. We actually like the fraction here. Again, I'm not trying to convince you like fractions. I'm just telling you, in this particular case, that the fraction actually sort of helps. That's going to come up later in the lesson. Very soon, actually. That in this case, in the case of fractions, or in the case of graphing, fractions aren't a big problem. They sort of help us. And just in case you got lost in all those previous lessons and didn't know why we were writing, therefore the point of intersection is, well, here it is. What is the point of intersection? Can you see it there? It's the point of intersection. 2 comma negative 1. I don't know. Some people, after days and days of algebra, actually will go, you know what? In my head, I thought I hated graphing. But now that we're going back to do it, maybe I like it better than the algebra. We got to do both. On this test, you got to be able to graph, like this. You got to be able to do substitution, which I'll review in a second, and elimination. I'm going to do 2 of each, 2, 2, and 2. You have any questions about graphing? Can we do another one? Oh yeah, let's do another graphing one. Just to make sure you got it. You got 2 reference pages. Do you need more time for this graph? Who needs more time?
I need like a second.
Another second. I think I saw you in Paris this morning. I think I saw you in Paris this morning.
In Paris? Probably would.
Yeah, we drove right by. I didn't clue in until I was like, hey. And I waved, but I was way too far gone. We drove right past you, coming out of the downtown Paris. Guess you have more time? It's good. More time? All right. Why is this question well suited for graphing? I'm going to keep it short here. Yeah, I'm not going to get technical or mathy here. I'm just going to tell you why that question was well suited for graphing. They were both y equals. If they're both y equals, you're not going to find graphing to be a big problem. Yeah, it should be pretty straightforward if they're both y equals. Okay. Would this question have been good for substitution? Maybe you don't know the answer. Or maybe you're like, yeah, they're both y equals. Wouldn't they be great for substitution? I say, yeah. Yes. They were both y equals. So if they're both y equals, this is what this lesson is trying to teach. It's trying to say if they're both y equals, graph it, use substitution, you have your choice. So there will be something like, oh, I don't really like graphing. Oh, I don't really like substitution. No problem. If they're both y equals, you can do either one. Would this question be well suited for elimination? Yes. Elimination likes all questions. Okay, it's y equals, y equals. I could multiply one of them by -1. Yes. The y's match up. I think that's what a lot of people were saying, whereas match up. So this could be done by elimination as well. So on the test, I'm going to make it so it's like you have to show me each method once, but then after that you can choose. You can say, okay, I like this method best. That's what I'm going to use. I'll say it in the microphone. I'm an elimination guy. You give me a chance, I'll do elimination every time. Yeah, that's my favorite. Doesn't have to be your favorite. You can do what you want. Any questions there? More time? All right. You let me know one more time. I'm not trying to rush it. I'm trying to keep it going on a Friday, though. Ooh, fractions. You know, like if you don't like fractions, you're like, ooh, fractions. It's okay. It's graphing. It's graphing. Fractions aren't a big problem. First one, y-intercept -1. There it is. Let me label that on there for you. If you're still having trouble with graphing, there's y-intercept. And then there's the slope. It's already a fraction. You see, with slope, it's okay. It's perfect. Yeah, fractions, no problem. So, just some advice from Mr. Todd. If a question has fractions already in it, probably graphing's the way to go. You're probably going to find that the easiest thing to do. So, rise -2, run 3. Rise -2, run 3. Rise -2, run 3. That's enough, especially if I have my ruler out. I can just draw a line straight through. There it goes. First line. I did it in red, so you can see. Blue, graphing. Blue, 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 blue. There we go. Y-intercept, -9. Slope, what are you going to do to this one? It's got a 2. What are you going to do to it to be able to graph it? Over 1, yes. So up 2 over 1, up 2 over 1, up 2 over 1. I like going all the way across, but you don't have to. You've got your ruler. Actually, on the board, the straight line tool is just a smidge awkward, so it makes it much easier on the boards if I get all the points there. There we go. Do you see the point of intersection now? That's what we were finding all those days when we did all that elimination stuff. We were finding out where the lines would meet. And so point of intersection, 3, negative 3. Okay. There's my review of graphing, done. You've got 2 questions to reference when you have to graph, right built into this homework, yes? Any questions about that graphing question? Not at all. Do you need more time? Do you need more time? No, we're good. All right. Same question as the last one. Why is this question well suited for graphing? I'm even going to shorten it down. Both y equals. If they're y equals, graphing should go pretty fast. Why don't I like this one for substitution? What is it about this question where substitution might not be the greatest? They're both y equals, but what's the problem? Ah, maybe not. Maybe not substitution. It has a fraction. And for us, when it has a fraction, we're going to like graphing a lot better. What does the world do? Well, the world handles fractions. It goes ahead and deals with the fractions. But we're not going to. Yeah, we're going to be like, okay, if it's a fraction, I'm going to try graphing. Would this question be well suited for elimination? Maybe not. Same answer, maybe not. It has a fraction. I don't want you to think that mathematicians are actually scared of fractions. In other classes, we might hammer right through the fractions, but here we'll avoid them if we can. Yeah? Any questions about that? Do you need more time? All right. That's 2 of the 6 examples. This will be faster. I think substitution's way faster than graphing. That's what I think. I said, do this one by substitution. I'm going to try and write as little as I can. I'm going to steal something. I think it was Daniel, but I'm not sure. It was over here somewhere we were talking about it, and I got a new way to write this. Both are equal. That's what somebody said or wrote, or something like that. They're both equal. Y equals 4x minus 6. Y equals 2x plus 12. So 4x minus 16 equals 2x plus 12. I might have said that wrong there. I might have said incorrectly. But 4x minus 16 equals 2x plus 12. Once you get used to substitution, pretty nice in these particular case. Bang, got an equation. And we've been hammering away at our ability to solve these equations. We didn't start off super good at these. How do I move the negative 16 over? What happens when it moves over? Becomes a positive 16. I can feel it. Some people are answering that weren't 10 days ago, starting to go, okay, well, I can't do it all, but I can do some of this now. I can move the 16 over. Then bring the x's to the left-hand side. When positive 2x comes over, what happens to it? It's now negative 2x, or subtract 2x. I can collect those up. 4 xylophones, subtract 2 xylophones, there's 2 xylophones, and then finally divide it by the 2 to get 14. I think that's faster than graphing. Feels like less work when it goes well. But that's not all. I'm going to switch colors. Then take the 14 and sub it back into either one of these. I was talking to a couple people about this yesterday. Which one to sub into? It doesn't matter. You might make your life easier by choosing the right one. I chose the one that had no negatives in it. I'll write the fancy sentence. Sub x equals 14 into y equals 2x plus 12. So I get y equals 2 times 14 plus 12. Hopefully those steps don't cause you problems. You just have to multiply that out and add them up. 14 comma 40. Sort of a big number for the y here. I want you to think about that when we go to answer the next questions. Sort of a big number for y when this was all over. And that might affect our thinking as far as which method to use here. Questions? Do you need more time? Who needs more time? Yeah, let's go. Just checking my microphone. I didn't have a lot of time to charge it between classes. Oh, but it's at 3/4 charge. I'll make it, because I've done 3 of the 6 examples I'm going to do today. So if your brain's running out on a Friday, hang in there till I get to elimination, so I can review elimination 2. Because there's only 3 things in the test. Graphing, substitution, elimination. I haven't said that yet, but I'm just saying, there's nothing I'm going to add here. I'm going to do word problems on Monday, which scares people, but it's not. It's just graphing, substitution, elimination. It's all the same. Okay, carefully answer these to try to help. Why is this well suited for substitution? They're both y equals. Did I make a full sentence there? No. I'm trying to shorten it down for you. So you can just look at that and go, oh, both y equals. That's what I like for substitution. Would this be good for graphing? It's okay, but what is it about the answer that would have caused us a problem for graphing? The numbers are too big. If the numbers are big, imagine I tried to graph that. Let me go back to a grid. And the answer was 1440. You see what happens? You're like, well, I'll just use a bigger piece of graph paper. Then great. Like it. Yeah? Can work. So only if my graph paper was big. And otherwise, it would cause you a bit of a heartache there to try and find that. Is this well suited for elimination? Yes. Yes. Sure. Elimination, don't care. Elimination's like big numbers, negatives, positives, 2s, 4s, 7s, 11s. Elimination's like, I got it. That's why I like elimination. Any question I look at, boom. Of course, I'm not scared of fractions either. I know how to deal with fractions, so I'm not too worried about that. So, but if you don't like fractions, stick to graphing for fractions. Elimination handles any numbers. More time there? One more substitution. Solve by substitution. We found out in day 2 of substitution that both of them don't have to be y equals. As long as one of them is x equals or y equals, we're home free. So check this out. Sub x equals 10y minus 100 into equation 2. And if your brain is totally fried on a Friday, try to come back for a minute here. Because I think this is the toughest moment of the chapter. That's what I think. I'm going to write equation 2. 40y plus. Did I skip? Did I hiccup? Is Mr. Todd losing it there? You said you were going to write equation 2. I didn't really write it, did I? I wrote 40y, and then I said nothing. And then I wrote equals 200. And this is my dramatic way of trying to teach this. Is go, you're supposed to say, Mr. Todd, you forgot the x. I'm like, right. OK, write the x. Here's me writing the x. Look at it. I'm not going to write x. I'm going to write 10y minus 100. That, I think, is the toughest moment of the chapter, to know how to sub in not just a number, but a variable and a number. That's difficult to know to do that. After that, it's not bad. It gets better after that. 40 yogurts and 10 yogurts, 50 yogurts. It's not yogurts, it's wise, but it helps to think it through. Opposite of subtracting 100, adding 100. Oh, I almost skipped a step there. Geez, maybe I am rushing it on a Friday. Slow down. Opposite of multiply by 50, divide by 50. And 300 divided by 50, do I need my calculator for that? 6, he says. Then take that y equals 6 and sub it into, which one? 1, 2, or 3? I like this one. It doesn't matter which one. You'll get the same answer either way, but maybe you can make your life a little easier. Sub what? Jeez, I wrote y. Y equals 6 into x equals 10y minus 100. Ooh, my writing's getting awful here. Settle down. X equals 10 times 6 minus 100. And hopefully this is not the steps that upset you. That's not the toughest thing. 10 times 6. Yeah, 60. Then subtract 100. But don't be embarrassed if you need your calculator for that stuff. Your brain's working hard on learning substitution and elimination. If you have to use a calculator for other parts of it, that's okay. Look at, I'm starting to take out this. All the paraphernalia here, it's starting to bother me. Point of intersection. Oh, I think I forgot a step in one of the questions here. Let me check. Point of intersection, 6, negative 40, comma 6. Did I forget? No one stopped me. Did I forget the other one? My brain's telling me I forgot. No, I didn't forget. I'm such a liar. Okay, I didn't forget. Negative 40, comma 6. That's going to matter when I go to answer these next questions. See if you can answer the next questions. Any questions? Do you need more time? Yes, more time. All right. We're almost done. We're 4/6 the way done. Well, two-thirds. Two-thirds. She reduced the fraction. 2/3. That's good. It's Friday. I can feel it. Did anyone go outside for lunch? Is it warm out there? Yes. Looks nice, doesn't it? Let me ask you this. If I organized the lesson that took us outside, would you be nuts or would you sort of try to listen extra while we were out there? You know what? The outside lesson I have in mind, you don't really have to write anything down. You don't have to write anything down. You just have to listen. I'll think about it. Doesn't work if everybody's late. I lock the door when the bell goes. So if I had to open the door for you.
So I was like right on, I was within the minute, I think, though.
That's not how late works. There's late and not late. There's not a minute.
What if he was like on time? What if he was like right like on the minute as the note?
No.
That's still late.
Yeah. When the bell rings, once it finishes ringing, you're late.
What if it wasn't the best time?
That would make my day if you were that close to the line, buddy. Did I give everybody enough time there? I hope so. Why is this question well suited for substitution? One equation was x equals. And if you think I'm changing the game, I'm not. On day 1 of substitution, I acted like they both had to be y equals. On day 2, it's like, oh, as long as one is. As long as one of them is y equals or x equals, you're okay. Okay? So think about that with substitution. If you got 1 as x equals, it's pretty good for substitution. Would this be well suited for graphing?
No.
Probably not. Answer had big numbers. And just to rewind in the chapter, that's why we came up with substitution. Graphing wasn't good for big numbers, and it wasn't good for decimals and stuff like that. So it wasn't always a good choice. Would this be well suited for elimination? Yeah, elimination is like, yeah, whatever. I don't care. Crazy numbers, negatives, 2s, 7s, 11s, don't care. Maybe fractions. Maybe fractions is elimination's weakness. Okay, so if it's fractions, go to graphing. That's the turning point of this lesson. Now we get to do elimination. Some of you are struggling with elimination. I get it. Some of the details are hard to get it all to work out. But elimination is very powerful. It can handle every situation very nicely. Questions before I do these last two elimination ones? (2x plus 3y equals 8, 5x minus 3y equals negative 1). Why is this one? Okay, if you don't get all the elimination questions on the test. Okay, but geez, you got to get this one. It's set up for elimination. That's Mr. Todd typing up question E, in this case going, let me give them an elimination one that's nice. What did I do?
3y.
3y is the first one. And what's the second one?
3y.
No. Yes. Negative 3y. You can just add them straight up. This is the nice elimination question. Are there some tougher elimination questions? Sure. But when it's positive something and negative something, those things just go. Here it goes. What's 2 and 5? 2 xylophones. 5 xylophones. 7 xylophones. Positive 3y.
7.
Negative 3y.
Oh,
0.
0.
8 and negative 1 is 7. Now come on. Hopefully you're still with me enough to go, okay, that I like. When that happens, I like that. That's nice and easy. I got to do the opposite of multiplying by 7 to get the x. So that's a little tiny bit of work. But compare that to the ones we were just doing that had like 11 and 12 lines of algebra. This is nice. One extra thing, put the x equals 1 back into, I'm going to sub it into the first one. So this is a little bit of work. What's 2 times 1? 2. What's the opposite of adding 2? Minusing. He's getting so good at it, he's not even listening. And then take the 6 and divide it by 3. Okay, that's why I like elimination. Lots of times it takes positives, negatives, 2s, 3s, 6s, 5s, bam, bam, done. Okay, but some of you are like, it's not always quite that easy. You chose a really easy one. Yeah, okay, I'll do a slightly harder one in just a second. Okay. After we talk about why this is so good for elimination and it would stink for the other two methods. It would be terrible to do it as a substitution or a graphing. That would just be horrifying. Do you have questions about elimination, though? More time? All right. Why is this question well suited for elimination? It had, oh, which way around was it? Was the first one positive or negative? Pressing the wrong button there. Positive 3y. It had positive 3y and it had negative 3y. Should I have wrote more there? Yeah, I probably should have. But I'm really trying to write something that's going to help you. Now, why that one was so nice for elimination is it had a positive 3y in the first one and a negative 3y in the second one. That was good like that. Would this be well suited for graphing? No. What was it about the whole situation that made this difficult for graphing? No y equals. And it would be hard to put it to y equals. It would be a lot of work. Could it be done? Yes, but geez, wow. Well suited for substitution? No. no y equals. We need at least one y equals for substitution. Or an x equals. That will work too. Is that a proper sentence? Would the English teacher love what I just wrote there? No, but you might love it when you look back at these sheets to study. You might love the way I wrote that. Do you see why I like elimination? On the other questions, elimination is like, well, I could do it. Elimination, all the other questions, elimination is like, I could do it. Get to this one, elimination is like, yep, got it. And substitution and graphing, you're like, I don't know. It's not going to be great, yeah? One more to go. Do you have any questions about that one? Do you need more time? Last one, last one, last one. Is it the hardest elimination question ever? No, but it's pretty close. Look at, nothing matches up. 3x doesn't match up with 4x. 2y doesn't match up with 6y. Who's got this under control? Who can give me some advice? A bunch of people do. There's a bunch of people that are like, oh, I got this now. I can handle this. They were running into some problems with some negatives and stuff like that, but mostly they knew what the plan was. Joseph, what are you going to do here?
Go to the top one and if you multiply by 6 and if the bottom one multiply by negative.
He's got it all under control. Okay? Let me just show you what he's up to in slow motion. He says take this whole equation. And if you want a shortcut to this, by the way, if you're like, I like elimination, but the writing's still too much, here's my shortcut. My shortcut is to put a big bracket around that thing and go, he says multiply that by 6. And if you're not sure why he chose that, just stick with us for a second and you might see where he got the 6 from. He didn't pick the 6 out of thin air. He didn't do some crazy calculation to come up with the 6. He knew exactly where to find the 6. And then he says multiply this one by negative 2. He chose negative 2 instead of positive 2. And if you doubt him, watch what he accomplishes. With the first one, I get 18x plus 12y equals 60. You go, okay, that's fine. Seems okay, Joseph. But why did you do negative 2 in the second one? Negative 8x minus 12y equals negative 20. See? Now they're both negative. Some people got themselves into trouble writing these up because they just try and rewrite one of the equations. Rewrite both of them every time. It keeps it all lined up nicely. Can you see what he's accomplished? I'll get my highlighter out and I'll just highlight. Is it a big highlighter? No, the biggest highlighter I got. There we go. I'm just going to highlight that. Right there. Just that. That's what he accomplished. By choosing 6 and 2, he got the y's to match up. He could have gone after x. He could have done that. The y was fine here. So where did the 6 and the 2 come from? How did he choose 6 for the first one? I think I put my hand in the right spot so you can see where the 6 is. He got the 6 from the second equation. How did he choose the 2 for the second one? Oh, he got the 2 from this equation. So they're not magic numbers. They're not hard to find. You just have to know to multiply by the number from the other one, from the other equation. Now the rest is pretty straightforward. Add the equations. I get 10x equals 40. Yes, you might need your calculator. I try to keep the numbers friendly, but even when I try to, once in a while, the numbers get a little out of sight, and then you go 40 divided by 10. 4? Then sub x equals 4. He likes into the top one, so I'm going to put it right there. Sub x equals 4 into that first equation, which was 3x plus 2y equals 10. 3 times 4 plus 2y equals 10. 12 plus 2y equals 10. Bring the 12 over. And then take the negative 2 and divide it by 2 and get the negative 1. Okay? I did those last few steps fast on purpose because those steps are part of all the questions. You're doing that over and over again, that sub and solve at the end. I'm not saying it should be easy, but you're seeing that a lot. That's very repetitive. Let me say it again. This upcoming test has graphing, it has substitution and elimination. You got to do every method at least once, and then after that you can choose which method is best for you. So I've given you another whack of practice ones there. How many is there? I still got to do the summary, I know. How many questions did I give you? 1, 2, 3, 4. Yeah? Not a lot, just a chance to try each method another time. Mr. Todd, I'm still not sure when to use each method. Good, I'm going to write it with as few words as I can in 3 boxes on the next page. Okay? I've got to answer those 3 questions at the bottom of the page, but then I got the 3 boxes coming up. I went through fast through that last part. Do you have any questions about the last part? Do you need more time? Yeah. Yes? Okay. It's good? Okay. Why is this question well suited for elimination? It has all different numbers. And because the numbers were all different, elimination can handle it nicely. Would this be well suited for graphing? No. No y equals, and not just no y equals, it would be difficult to do. It would be difficult to make y equals. Would it be good for substitution? No. No y equals or x equals. And it would be difficult to do it. Those would be some words maybe I should have added on there. It wouldn't be easy to do it. All right, I need somebody else's words here though. Let's try and use as few words as possible in these next 3 boxes. Not because I'm tired, not because you're bored, but because I want you to be able to look at this and go, when would I use graphing? When would you use graphing? What should the equations look like if we're going to use graphing? Joseph. Both y equals. If they're both y equals, graphing. And I'll write here fractions. No prob, Bob. Called myself Bob there. If there's fractions, no problem, Bob. It's not, fractions aren't going to bother you at all. Even if you hate fractions, you're going to like having a fraction in the slope anyway, so you don't care. Did you get time to write down no prob, Bob? We got it, Bob. Substitution. They don't need to both be y equals. At least one is y equals or x equals. If you see one of them that is y equals or x equals, it should work. Don't love fractions here. We don't love fractions for these ones. That's the weakness of substitution. You don't have to take my word for it, but for elimination, I'm going to write whenever I can. I would use elimination whenever I'm allowed to. Yeah? It's the nicest of the 3. Overall, fractions, again, are a bit of a problem for elimination. Did I write it short enough? It was meant to be short. I didn't want some long essay you wouldn't read later. I want you to look at this and go, oh yeah, substitution, y equals x equals. I use elimination. Whenever I can. Also no love for fractions here. But you can decide for yourself How are you going to know? Well, you got to practice. You got to do some practice once so you know how to handle each situation. Do you have any questions?